In this part file, I have the original model itself, and that's what we're going to develop from. And then here you see the develop form that we're going to use blank on binder with. Also, you'll see that I have the tool form, and that is what we're going to use the Springback Deform function on to capture the opposite effects of the springback. So the first thing we need to do is to get the springback data. And here I'll use blank on binder. We'll select the binder, or the part that has the flange extruded out sideways, and then we're going to pick the original data of the model. Set the material properties if they haven't already been done so in a setup file. Perhaps if you're using an actual die assembly to do that. I'll just pick something kind of middle of the road, pick 350. Alright, now we need to calculate so that we get that development. So take a second or two, and the whole purpose behind this again is to get those points that we can later use for Springback Deform. I use this on a single part file in this demonstration just because it's easier to work with and everything is all right there. I don't have to hop in and out of one part or the other. Okay, now that that's been done, we will go ahead and set up for the deform. Alright, so all I need to do is to go into my analysis. Here I need to do the actual springback calculation. I'll go through the thickness strain. Here's the safety zone. Everything looks pretty decent. Now we'll go into springback. Obviously I want to capture the springback on the outer edges, so we're going to use the geometry along the inside against the part of the data that doesn't move. So take a second and pick my way through this back edge. Obviously the more I pick, the more accurate I'll get as a result. Now we'll do the analysis. So here you can see that in the red areas we're showing as much as 60 thousandths of springback in those outer edges. So that's what we would anticipate. Now from here we can save this as a CSV file, and that would be one way in which to bring it in to do the deform. So just type in the name I want. Or we can also use the data itself right from within the system as it's been saved. So it's nice to have both those options. Alright, now we'll bring the block up, turn off all the data that I don't need here. Here you see the form station, and also in this purple you see I've got the original part file itself that I'll later compare that to. So now we'll use Springback Deform, select the block that I want to have deformed, and then we're going to go right into the deform function using the points. Alright, again you could bring in that point file, the CSV file, or in this case I'll just import the calculation we just did. You can see the number of points that are brought in and how they're laid up right against the block. Those little arrow vectors define the direction in which the springback is going to take place. Typically I use about 80% of the total springback. That way there's a little bit of extra steel for safety conditions. We'll calculate where the points need to go when generating the data for the springback calculation. Now we just simply need to execute this. Alright, so now that's been accomplished, we'll turn on the original part data. Zoom up in here and you can see the purple represents the inside surfaces of the part, and you can see how far away now the actual tool form is in the opposite direction of the springback. Very useful tool then in being able to successfully accomplish this and compensate for springback.